After several years of determined development, the United States has finally unveiled its quiet supersonic aircraft. The X-59 is said to be the very first quiet supersonic aircraft, and this achievement has reignited hope for commercial supersonic flights. With its advanced and powerful engines and designs, the US has once again pushed the boundaries of technology, shocking the world in the process. What effect will the X-59 supersonic aircraft have on the world of aviation? What are the capabilities of this new supersonic aircraft? Join us as we explore the features of the United States Air Force's stealth X-59 megasonic aircraft. Speed has always been a crucial factor whenever creating a military weapon. However, the phenomenon known as the sonic boom has long been a significant drawback for supersonic aircraft. This phenomenon occurs when an aircraft exceeds the speed of sound, causing compressed air molecules around it to create shock waves that merge into a loud, disruptive noise known as a sonic boom. This noise is quite audible on the ground and has historically hindered the commercial feasibility of supersonic travel over land. Many of the issues associated with supersonic flight can be traced back to the Concorde, the renowned supersonic passenger jet developed by France and the United Kingdom. The Concorde had the capability of flying from New York to London in just 3.5 hours. When the Concorde first took flight in 1969, it captivated people with the promise of incredibly fast air travel. However, the excitement diminished when they experienced the noise it generated. As the Concorde broke the sound barrier, it produced a thunderous boom that sounded like an explosion, shattering windows and causing doors to tremble. Its powerful engines caused a loud sonic boom with a pressure of about 2.2 pounds per square foot. Because of this noise, many countries banned supersonic flights over land or populated areas. The FAA also restricts supersonic flights over land except in certain military zones. When planes started flying faster than the speed of sound over the US, the noise became such a problem that Congress banned civilian supersonic flights over land in 1971. This ban was officially put into effect in 1973 and was later adopted worldwide. Nevertheless, in 2016, NASA asked Lockheed Martin and other companies to submit a proposal for a test aircraft that could demonstrate that supersonic flight over land was safe and as silent as regular subsonic airliners. The target was to make a plane with a boom of just 75 perceived loudness in decibels, a unit that measures how people perceive sound, as opposed to the actual decibels produced by the sonic booms. A 75 perceived loudness is equivalent to hearing a dishwasher for less than a second. For comparison, the Concorde's perceived loudness was 105, or as loud as listening to a chainsaw at full power. In 2018, NASA awarded Lockheed Martin a $247.5 million contract to develop a truly quiet supersonic jet. By November 2018, Lockheed Martin had initiated the machining of the X-59's first part in Palmdale, California. Major structural components were assembled by May 2019. This aircraft was initially set to start flight tests in 2021, but encountered some delays. However, after overcoming these stumbling blocks, it is now scheduled to be delivered to NASA for testing in 2024. The plane is expected to fly at Mach 1.42 and at an altitude of 55,000 feet, producing a low noise level of 75 effective perceived noise decibels to test the feasibility of quiet supersonic travel. There are plans to undergo various tests before moving to NASA's Armstrong Flight Research Center in late 2024. It will fly over 6 different United States neighborhoods to gauge public reactions. The goal is to make supersonic flight over land acceptable and potentially change current regulations. Recently, NASA installed a powerful engine on the X-59 in early 2024, indicating that the aircraft would be ready sooner than later. The General Electric F414G100 engine, which powers one of the most powerful fighter jets in the US Navy, the F/A-18 Super Hornet, found its place in this supersonic aircraft. However, the engine is positioned at the top rather than the bottom of the plane to maintain a smooth, loud profile that prevents shock waves from reaching the ground. The aircraft has since undergone a series of tests, from weight checks and fuel system evaluations to ground vibration assessments. Remarkably, the X-59 weighed in below the anticipated weight, a rare achievement in aircraft development that surprised the entire team. The plane, about 100 feet long, is built with a sleek design to reduce sonic booms. It is expected to be much quieter than the Concorde, aiming for only 75 decibels of noise at supersonic speeds. However, this supersonic aircraft is simply a technology demonstrator, and future passenger supersonic planes may look different, but could use some of its design ideas. The X-59 was rolled out in front of cameras in August 2023, before going into the paint barn for its final red, white, and blue paint job. Finally, NASA and Lockheed Martin formally debuted the agency's X-59 quiet supersonic aircraft on Friday, January 12th. According to NASA Deputy Administrator Pam Melroy, it is a major accomplishment made possible only through the hard work and ingenuity of NASA and the entire X-59 team. In just a few short years, they've gone from an ambitious concept to reality. She points out that the supersonic aircraft will help change the way we travel, bringing us closer together in much less time. Following the unveiling, Lockheed Martin emphasized that this supersonic marvel opens doors to various applications, including rapid medical response, shorter shipping times, and, of course, faster travel. When the curtain finally fell to reveal the X-59, the assembled crowd applauded and held their mobile phones aloft to capture photos of the new jet, shining red and blue under stage lights. During that rollout, the striking and unique geometry of the aircraft was on full display. The aircraft features a sharp, elongated, beak-like nose section that measures 38 feet in length. This nose section will help shape the shock waves the aircraft produces during flight. NASA stated in a 2021 statement that the nose also means pilots flying the X-59 can't see out of the jet's forward windscreen because it doesn't have one. Instead, pilots use what NASA calls the External Vision System 15s to see in front of the aircraft. This system uses a forward-facing camera, a cockpit-mounted display screen, and custom image processing software to create an augmented reality view of the pilot's forward line of sight, along with graphical flight data overlays. As exciting as the unveiling is, it's only the beginning for the supersonic marvel. According to Catherine Baham, manager of NASA's Low Boom Flight Demonstrator Project and development led on the X-59, the rollout is a major accomplishment, but it also means the next milestone is the first flight and then supersonic flights after that. She emphasized their focus on the mission. With the rollout complete, the QSD team will shift to its next steps in preparation for the first flight, including integrated systems testing, engine runs, and taxi testing for the X-59. The first flight of the supersonic aircraft was anticipated to take place last year. However, in October, agency officials delayed the inaugural flight to 2024, citing several technical challenges identified over the course of 2023, including intermittent issues with some of the safety redundant computers. The QSD team will conduct several of the aircraft's flight tests at Skunk Works before transferring it to NASA's Armstrong Flight Research Center in Edwards, California, which will serve as its base of operations. Once the X-59 has flown over the half a dozen residential communities across the US selected to offer a diverse mix of geographic and atmospheric conditions, NASA will engage with the communities on the ground to gauge their response to the noise. The goal is to confirm the theory that a 75 perceived loudness in decibels will be acceptable. The data gathered in this way will then be presented to the US Federal Aviation Administration and international regulators. NASA believes that a change in regulations would open up the skies for a new generation of supersonic aircraft allowed to fly over routes that aren't permitted now, such as New York to Los Angeles, flight time roughly in half. However, nobody knows what those new aircraft will look like and who will build them, because the X-59 is not a prototype, but merely a technology demonstrator. Several companies are currently developing supersonic passenger aircraft and plan to fly them within a decade or less, including Hermes, Boom, and Spike. However, it's doubtful that any of them will be able to take advantage of the findings of the QSD program, which will likely inform the next generation of supersonic aircraft. Such aircraft, with the ability to fly anywhere, would democratize supersonic travel, marking a stark difference with Concorde's luxury status. Let's check out the features of the first supersonic fighter that was used commercially and compare it to the X-59's design. The Concorde was a unique aircraft, distinguished by its tailless design and narrow body, accommodating 4 seats across with space for 92 to 128 passengers. It featured a distinctive curved delta-shaped wing and a nose that could tilt downwards for improved visibility during landings. Powered by 4 Rolls-Royce Snecma Olympus 593 turbojet engines equipped with adjustable air intakes, it had the capability for extra power during takeoff and supersonic flight. Constructed mainly from aluminum, it was the first passenger aircraft to use analog fly-by-wire controls, enabling it to reach speeds up to Mach 2.04 and sustain these speeds at an altitude of 60,000 feet. This allowed passengers to see the curvature of the Earth and experience shorter flight times, such as a London to New York journey in just over 3 hours. However, it had a high fuel consumption rate of 46 liters per seat per hour and generated significant noise, which contributed to its eventual retirement. In comparison, the X-59 offers advanced technologies to overcome these limitations, with a focus on minimizing noise and enhancing efficiency. While the Concorde remains a remarkable milestone in aviation history, the X-59's design addresses the sonic boom challenge, aiming to make supersonic flight more practical and sustainable. The X-59 represents the future of supersonic travel, with the potential to revolutionize the way we fly, making high-speed air travel over land a reality once more.